Welcome everybody. Now we are going to discuss about SR latch. So already we have seen what is meant by latch. So latch is 1-bit memory cell. So you are familiar with the circuit that is shown in this figure 1. So this circuit contains two cross-coupled inverter. So we have seen that this is circuit of 1-bit memory cell. So here either I can store bit 0 or bit 1. So this circuit will have two stable state, one is logic 1 and second one is logic 0. But there is one problem with this 1-bit memory cell. So what is that problem? No way of entering desired digital information in latch shown in figure 1. Now suppose in this particular cell I want to store 1. How to enter that 1? So there is no way for entering information. Similarly, if I want to store 0, then there is no way of entering 0 in this particular cell. So this is problem with this particular circuit. Now when power is switched on, the circuit will switch to one of the stable state, that is either 1 or 0. We cannot predict. So when we apply power to this particular circuit, okay, at that time this circuit will switch to one of the two stable state. Which are that stable state? Either 1 or 0. But here we cannot predict what will be the state of this circuit when we apply power to it. Whether it will be logic 1 or logic 0. Right? So that's why it is required to modify this particular circuit. So see, now the circuit has been modified like this. So this circuit is called as SR latch. So this is latch, means in this circuit also we can store 1-bit data. So if you observe this circuit diagram carefully, you will come to know that this circuit also contains cross-coupled inverter. So see, output of N1 is connected to input of N2, output of N2 is connected to input of N1. So this circuit also has cross-coupled inverter. So in this circuit also we can store 1-bit data. Now, what is difference between this circuit which is shown in figure 1 and the circuit that is shown in figure 2? So here you will find two more NAND gate. Here we were having only two NAND gate, that is 1 and 2. Here we have now total 4 NAND gate, 1, 2, 3, 4. So this NAND gate N3 and NAND gate N4 has been added in this particular circuit, so that we will get circuit which is shown in figure 2. So why these two NAND gates has been added? So by using these two NAND gates, okay, we can enter information, desired digital information in this particular memory cell. Suppose you want to store 0, then you can apply proper input to yes and R. So what is yes? Yes is input for NAND gate N3 and R is input for NAND gate N4. So if you want to store 0, you have to apply some proper input to yes and R. If you want to store 1, you have to apply proper input to this yes and R. So in this way, this 1-bit memory cell, circuit diagram of 1-bit memory cell has been modified so that we will get circuit diagram of SR latch. So we are going to perform analysis of this particular circuit. Now let's do analysis of SR latch. Now in this circuit, please try to understand that NAND gate N1 and NAND gate N2, they will act as 1-bit memory cell. So by using these two NAND gate, it is possible to store either 1 or 0. And by using NAND gate N3 and NAND gate N4, we can store either 1 or 0 in this particular memory cell. So how it is possible, that we are going to see. Now before discussing analysis of this circuit, let's go through truth table of NAND gate. So this is truth table of NAND gate. So from this truth table, it is clear that output of NAND gate will be 0 when both inputs of NAND gate will be 1, 1. Otherwise, output of NAND gate will be 1. Now here I will like to ask you one question. Suppose consider this NAND gate N1. So here suppose I know that this one input of NAND gate N1 is 0. And suppose I don't know other input of this NAND gate N1. So in this case, can I predict what will be the output of this NAND gate N1? If we know that one of the input of NAND gate N1 is 0 and suppose we don't know what is status of other input, whether it is 1 or 0. So can we predict what will be the output of that NAND gate N1? So see this truth table. So from this truth table it is clear that, so see, here we have 0, here we have 0, here we have 0. Okay, now here there is no 0. So when one of the input of NAND gate is 0, I can say that what will be the output of NAND gate? So output of NAND gate will be 1. Okay, so now come back to this particular question. What I asked that here, if we know that one of the input of NAND gate is 0, can we predict output? Yes. So if we know that one of the input of NAND gate is 0, then directly we can say that output of that NAND gate will be 1. Now second question. Suppose we know that one of the input of this NAND gate N1 is 1 and we don't know other input. So in this case, can we predict what will be the output of this NAND gate N1? So see this truth table. So here we have one of the input of NAND gate 1, then here also we have 1, and here also we have 1. So in this case, if we know that one of the input of NAND gate is 1, in this case, whether output will depend upon this second input? Is it compulsory that we must know this second input? So just see this truth table. So here, which is second input? 0. What is output? Output is 1. Now here, which is second input? Second input is 1. So what is output? Output is 0. So in this case, can I say that output of this NAND gate N1 will depend upon this second input? If we know that one of the input is 1, then can we directly predict output of this NAND gate N1? No, we cannot directly predict the output. So here output will depend upon this second input, because see this truth table. Here if second input is 0, output of NAND gate will be 1, and if second input is 1, output of NAND gate will be 0. So here I can say that if one of the input of NAND gate is 1, I cannot predict what will be the output of that NAND gate N1, whether it will be 1 or 0. So now we can conclude that if we know that one of the input of NAND gate is 0, then output of NAND gate will be always 1. So in this case, it is not required to know status of other input of that NAND gate. Now let's see analysis of SR latch. So here we have two inputs S and R. So by using these two input, how many possibilities are there? 2 raised to 2, that is 4 possibility. Which will be those 4 possibility? Either both input of SR latch will be 0 0, or both input will be 1 1, or S is 0, R is 1, or S is 1 and R is 0. So let's see how this SR latch will behave in all these 4 cases. So let's start with case number 1. So case number 1 is S is 0, R is 0. Okay. So let's see how this SR latch will work if both inputs of SR latch are 0 0. So here we will make one assumption. What is that assumption? Assume initial Q is equal to 0. Please try to understand. Here we have made this assumption that what is initial value of Q? Initial value of Q is 0. Okay. So here I will use one more word, that is state of the latch. So when I say state of the latch means what? I am going to refer value of Q of this latch. Okay. So when I say state of the latch, so state of the latch is nothing but value of Q. So value of Q at one particular time will represent state of this particular latch. So state of this latch will be either logic 1 or logic 0. So here we have assumed that what is initial state of this SR latch? Initial state we have assumed that it is 0. Okay. What input we apply to SR latch? 0 0. Now after applying input 0 0, we are going to see whether state of this latch is going to change. What change is going to happen in state of latch if I apply this input? Okay. So let's start. So what is the value of S? So here we have assumed that S is in this case S is 0 and R is 0. So see NAND gate N3, what are inputs of NAND gate N3? So both inputs of NAND gate N3 are connected together. Similarly, both inputs of NAND gate N4 are connected together. So what will be the output of NAND gate N3? So see truth table of NAND gate. If both inputs are 0 0, what is output of NAND gate? It is 1. So can I say that output of N3 will be 1 and output of N4 will be 1? Yes. Now this one will become input to NAND gate N1. This one will become input to NAND gate N2. Right. Now can I predict output of this NAND gate N1 and NAND gate N2? No, because here I know that one of the input is 1, but I don't know other input. So here if we know that one of the input, if we know that one of the input of NAND gate is 0, then only we can say that output of NAND gate will be 1. Now here we know that one input of NAND gate is 1, okay, and we don't know other inputs, so I cannot predict output of this particular NAND gate. Now see value of Q. Here what is value of Q? We have assumed that initial value of Q is 0. So this Q we have given as input to N2, okay, so which is other input to N2, it is 0. Okay, now can I predict output of this N2? What will be the output of this N2? So here one input is 0, other input is 1. So output of this N2 will be 1. That is Q prime will be 1. Okay, now this Q prime is given as input to N1. Okay, so this one will become input to N1. What are inputs to NAND gate? N1, 1, 1. So here both inputs are 1, 1. So see truth table, if both inputs are 1, 1, what is output of that NAND gate? 0. So what will be the next state of SR latch? So see, next state of SR latch will be 0. We assume that initial state of SR latch is 0. After applying input 0, 0, I am getting next state of SR latch again 0. So see, initial Q was 0. After applying S and R equal to 0, again we are getting next Q as 0. In this case, whether any change took place in state of that SR latch? No change. Now, let's make one more assumption. Suppose we have applied inputs 0, 0 to SR latch and initial Q is 1. Then what will happen? So see, here we have assumed that what is initial value of Q? Now initial Q is 1 and we want to determine next Q. Okay. And what inputs we applied? 0, 0. So here 0, 0. What will be the output? Here 1, 1. So this one will become input to N1. This one will become input to N2. What is initial value of Q? 1. So this one will become input to N2 because we have already applied output of N1 to input of N2. So this one will become input to N2. Here both inputs of N2 are 1, 1. What will be the Q prime? Yes, both inputs are 1, 1. So Q prime will be 0. So this 0 will become input to N1. So what are inputs to N1? One input is 1, other input is 0. So what will be the output of N1? So output of N1 will be 1. Right? That is new value of Q will be 1. Okay. Next value of Q will be 1. Right? So we started with Q equal to 1. We applied input 0, 0. And what is next state that we are getting? So next value or next state of SR latch will be 1. So again, please try to understand this case. We applied input 0. Okay, we assume initial Q 0. So what is new value of Q that we got? 0. Again, we assume that initial Q is 1. What is the new value of Q that we got? Again, it is 1. So can I say that in SR latch, if I apply this input, that is S equal to 0 and R equal to 0, whether value of Q is going to change? In other word, can I say that state of this SR latch is going to change? If previous state is 0, it will remain 0 only. If previous state is 1, it will remain 1 only. So what I can say about case number 1? So I can conclude that in case number 1, when S and R both are 0, 0, state of that SR latch does not change. It will remain as it is. Now let's see second case. So second case is S is equal to 1 and R is equal to 0. So if I apply this input, then what change is going to happen in SR latch? How this SR latch is going to work? Let's see. So here S is 1 and R is 0. So here again we will make one assumption regarding value of Q. So assume that initial Q is 0. So here we have assumed that initial value of Q is 0. So now we want to predict new value of Q. Next value of Q. So see here, what is input to N3? So both inputs are 1, 1. If both inputs are 1, 1, what will be the output of this NAND gate? It will be 0. See this truth table. Now here both inputs are 0, 0. Output of this NAND gate will be 1. Okay. Now this 0 will become input to NAND gate N1. This one will become input to NAND gate N2. Now we have assumed that initial value of Q is 0. So that Q will become input to N2. Right? So this 0 will become input to N2. And here what are inputs to N2? 0 and 1. So here 0 and 1. What will be the output of N2? So output of N2 will be 1. So can I say that Q prime will be 1? Yes, so this one will become input to n1, right? What are inputs to n1? One input is 0, other input is 1. So what will be the new value, or what will be the output of this n1? So output of this n1 will be 1, right? So that is new value of q will be 1, right? So what was initial value of q? So we assume that q is 0. What input we applied? We applied 1 to yes and 0 to r. So what is new value of q that we are getting? 1. So can I say that in this case state of SR latch has been changed? Previous state was 0 and new state that we are getting is 1, right? So see, we assume initial q 0 and then next q is 1. Okay, next value of q we are getting is 1. I hope it is clear. Now consider another assumption. Assume that new initial value of q is 1. So initial value of q is now 1. What are inputs? So S is 1, R is 0. So here it is 1 1. So output will be 0. Here output will be 1. So this 1 will become input to N2. This 0 will become input to N1. Right? Now here what is initial value of Q? Initial value of Q is 1. So that here 1 will become input to N2. Okay. So here both inputs of N2 are 1 1. What will be the output? So Q prime will be 0. See this truth table, both inputs are 1 1, output will be 0. So this 0 will become input to n1. Both inputs of n1 are 0 0. So what will be the new output of n1? Yes, so new output will be 1. What was previous value of q? 1. What is new value of q that we are getting? 1. So see, same statement is written here. Initial value of q is 1. We applied this input and then next value of q is 1. Now observe this case number 2. What conclusion we can make regarding case number 2? So here S is 1, R is 0 and C. What is the next state that we are getting? So here we are getting next state of SR latch as 1. Right? Here we are getting next state of SR latch as 1. So I can say that this particular case corresponds to set state. Because if I apply this input S equal to 1 and R equal to 0, then next state of that SR latch will be always 1. So I can say that if S is 1 and R is 0, if S is 1 and R is 0, then in this particular memory cell, which value will be stored? 1. Now let's see case number 3. Case number 3 is S is equal to 0 and R is equal to 1. So S is 0 and R is 1. So in this case, let's see how this SR latch will behave. So assume initial Q is 0. So here again we will make one assumption that what is initial value of Q? Initial value of Q is 0. Now we want to determine next Q. So let's start. So see, both inputs of this NAND gate N3 are 0. So what will be the output? Here output will be 1. Now see, here both inputs of this NAND gate are 1. So what will be the output? Output will be 0. Right? Now initial Q is 0. So that 0 will become input to N2. So this 0 will also become input to N2. So here both inputs of N2 are 0 0. So what will be the Q prime? So Q prime will be 1. So this 1 will become input to N1, which is other input to N1. So this 1 which is generated by N3. So both inputs of N1 are 1 1. Okay, so both inputs are 1 1. So what will be the output of N1? So output of N1 will be 0. Okay, so this is next state of Q. We started with initial Q 0. Okay, we applied this input, and what is next Q that we are getting? 0. Clear? Now consider next possibility. Assume that initial Q is 1. So here S is 0, R is 1, and here now we assume that Q is 1. So if initial Q is 1, then let's see what will happen. So here both inputs are 0 0, output will be 1. Here both inputs are 1, output will be 0. So this 0 will become input to N2. This 1 will become input to N1. Then this 1 will become input to N2. Here inputs to N2 are 1 and 0. So what will be the Q prime? So Q prime will be 1. Right? Now this 1 will become input to N1. Both inputs of N1 are 1 1. So what will be the output of N1? Yes, it will be 0. So see, we started with initial state 1. Okay, we applied what input? S equal to 0 and R equal to 1. So what is next state of Q? So next state of Q is 0. Okay, we started with initial Q1, we applied this input, and then we are getting next Q as 0. So see, next Q which we are getting here. So here next Q is 0, here also next Q is 0. So what we can say about case number 3? So here I can say that in SR latch, if I keep S equal to 0 and R equal to 1, then always next Q or next state of SR latch will be 0. So here I can say that case number 3 correspond to reset state. That is, SR latch is going to reset, means its output is going to become 0. So if I want to store 0 in SR latch, then I should apply this input to SR latch, that is S equal to 0 and R equal to 1. Now let's see case number 4. So case number 4 is S is equal to 1 and R is equal to 1. So see, S is equal to 1 and R is equal to 1. So let's try to understand how SR latch will work if both inputs are 1 1. So here both inputs of NAND gate N3 are 1. So what will be the output? Here output will be 0. Similarly, here both inputs of NAND gate N4 are 1. So here output will be 0. So this 0 will become input to N1. This 0 will become input to N2. Okay, now consider this statement. What we said? We said that if we know that one of the input of NAND gate is 0, then output of NAND gate will be always 1. So here I know that one of the input of NAND gate N1 is 0. So what should be the output of this N1? So output of this N1, it should be 1. Similarly, see this NAND gate N2, what is one of the input of this NAND gate N2? It is 0. So what will be the output? What should be the output of this NAND gate N2? So it should be again 1. So now consider what is happening on output side. So see, here we are getting value of Q as 1. We are also getting Q prime as 1. So whether it is possible, it is not possible. So when we discuss 1-bit memory cell, at that time I told you that, so when Q is 1, Q prime must be 0. And when Q is 0, Q prime must be 1. So whether it is happening if S is equal to 1 and R is equal to 1? No. If S is 1 and R is 1, both Q and Q prime will try to become 1. Okay, so that's why we can say that this particular combination is invalid in SR latch. It is not allowed in SR latch because both Q and Q prime tries to become 1. So that's why it is invalid. This particular condition is not allowed in SR latch.